students. You're welcome to Eko Learners Support for WAEC and NECO candidates. I'm going to be teaching you energy in physics class today. Let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Energy, that's our topic for today. The learning objectives for this topic is, by the end of the lesson, you will be able to define energy and list the two major types of energy. 2, you'll be able to differentiate between various forms of energy. 3, you'll be able to explain the principles of conservation of energy. Energy is the ability to perform work. The unit of energy is joules, and it is also the same as the unit of work. Energy is found in many things, and thus there are different types of energy. All forms of energy are either kinetic energy or potential energy. The energy in motion is known as kinetic energy, whereas potential energy is the energy stored in an object and is measured by the amount of work done. Potential energy, like we said, is a stored energy. Take, for instance, the spring. The compressed spring has potential energy. When released, it can do work, which is the mass m. Then we have gravitational potential energy, that is the energy of position. Other forms of energy, we have mechanical energy, sound energy, heat or thermal energy, chemical energy, electrical energy, nuclear energy, solar energy, light energy, amongst other forms of energy. Law of conservation of energy states that energy can neither be created nor destroyed, but it can be transformed from one form of energy to another. Take, for example, your pressing iron. Once you plug it to a socket and there is a form of electricity, it is converted, energy is converted from electrical to heat energy. That is for the pressing iron. Your battery or your cell, the energy is converted from chemical to electrical energy. Telephone earpiece, it's from sound to electrical energy. Once you pick it up and you speak into it or you listen to it, that is from sound to electrical energy. Then your fan, your ceiling fan at home, is from electrical energy to kinetic energy, and so on and so forth. Simple calculations. Kinetic energy. This is the energy possessed by an object in motion, and the formula is given as half mv squared. While potential energy is the energy of an object at rest and is given as mgh. Okay, let's look at this calculation. Example 1. A ball of mass 250 grams is kicked by a force which makes it move with a speed of 20 meters per second. Calculate the kinetic energy possessed by the ball. The solution, remember, we are to calculate for kinetic energy, and previously I told us the formula for kinetic energy is half mv squared. So we are already in the question. We have our mass as 250 grams and we have our velocity as 20 meters per second. So given that m equals 250 grams, is converted to kilogram, and we have 0.25 kilogram, and the velocity is 20 meters per second. So slotting the values into the formula, we have half multiplied by 0. The converted version of the mass, 0.25 multiplied by the velocity, 20 squared. We have our solution. By the time you use your calculator, we have the answer to be 50 joules. That is the kinetic energy used by the ball when the ball is kicked. Example 2. A boy of mass 20 kilograms climbs a staircase of 10 steps each, of height 0.5 meters. Take note, 10 steps each of height 0.5 meters. Determine the potential energy of the boy after attaining the final destination. Remember, we said potential energy is energy at rest. That's why they said calculate the potential energy after attaining the final destination. So, we are taking G as 10 meters per second square. Now, from the question, like I told you, the height is 0.5 meters, and they said the boy took 10 steps. So we have to multiply that to get the total height for the boy to attain the final destination. And putting the values back here, we have our mass as 20 kilogram, and we have the gravity as what? 10, and we have acceleration due to gravity as 10, then we have the height now as 5 meters. So when you multiply it through, you have 1000 joules. So the potential energy of the boy after attaining the final destination is 1000 joules. Practice question. The first one states the law of conservation of energy. Going back to the learning objectives, we expect you that at the end of the lesson, you should know the law of conservation of energy. Then give energy transformation that takes place in a telephone earpiece. And lastly, you should be able to calculate the value of the velocity of a toy car of mass 10 kg if its kinetic energy is 1000 joules. I'll give you 30 seconds and I'll be right back to cross-check your answers with mine. You're welcome back. So I guess you have gone through the questions. Let's roll together and see how we synchronize. Answer to the practice question. State the law of conservation of energy. And the answer simply is, the law of conservation of energy states that energy can neither be created nor destroyed, but can be converted from one form to another. And the second question says, give energy transformation that takes place in telephone earpiece. Like I said, the answer is electrical to sound energy. And from the mouthpiece, it is sound to electrical energy. Calculate the value of the velocity of a toy car of mass 20 kilogram if its kinetic energy is 1000 joules. So we have the mass to be 20 kilogram, we bring out the parameters, and we have the energy, like we are told, to be 1000 joules. And you know that V is square root of 2E over M in brackets. So remember, you already have our E to be 1000 and divided by mass, which is the 20 kilogram. So when you slot in the values into the formula, it gives you this by the time you use your calculator, and your V is getting the square root of 100, you have 10 meters per second. I hope you get the same answer as mine. So for further questions, comments, observation, kindly visit the social media that will be shown on the screen and contact us. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Good day, students. Again, you are welcome to Eko Learners Support for WAEC and NECO candidate. You'll be having me again today as your physics teacher, and we'll be taking the topic temperature and heat. Let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Like I said, we'll be considering today heat and temperature. Heat and temperature. What are our learning objectives? They are distinguish between heat and temperature. Explain temperature points. Explain temperature scales. Convert a given temperature on the Celsius scale to a temperature on the Kelvin scale and Fahrenheit scales. What do we mean by temperature? When we were small, our mother will normally check our body and they will say, "Oh, my boy is running temperature." That was an erroneous definition because temperature is actually the degree of hotness or coldness of a body. It is not just about hotness. And that is why you see me using that conjunction. Is the degree of hotness or coldness of a body. Temperature is measured in degree Celsius or Kelvin. Temperature is measured using a thermometer. On the other hand, heat is a form of energy that is transferred from one point to another due to temperature difference. Let me give you a crystal illustration, or let me be pragmatic. For example, why do you think so many people in Nigeria or Nigerians youth wants to travel abroad, which is commonly called Japa? Very simple reason. The reason is just because the living condition in either Canada or USA or Britain is better than our country, according to them. If I want to tell you, and you will agree with me, if the living condition in Nigeria is the same thing as the living condition in America or Canada, there is no need to japa. There is no need to travel. So in other words, if there is no reason, if there is no difference in standard of living, there wouldn't have been occasion for people living. And that is what happened to heat. Without change in temperature, there is nothing like heat. But when there is difference in temperature, then we talked about heat. And that one will let us to know that heat depends on temperature. Because once there is difference in temperature, then you measure. So without mentioning temperature, you can't measure it. So heat is dependent of temperature, but temperature is independent of heat. Temperature does not depend on it. For example, we have country, or we even have countries where they don't experience heat at all. Crystal illustration, some part of Canada, they have temperature as low as minus 20 degrees centigrade. So they don't talk of heat there. Australia, to mention but few. In other words, I'm establishing the fact that temperature is independent of heat, but heat depends on temperature. Having said this, we want to look at this temperature. Temperature has two fixed points. Two fixed points. They are, number one, upper fixed point, also known as higher fixed point. And the other one, lower fixed point, also referred to as lower fixed point, ice point. What is upper fixed point? Is the temperature of the pure boiling substance at normal atmospheric pressure, while the lower fixed point is referred to as the temperature of pure melting substance at normal atmospheric pressure. We need to know. We said upper fixed point or higher temperature is the temperature of pure boiling water at normal atmospheric pressure, while the lower one is the temperature of the pure melting substance at the normal atmospheric pressure. The difference between the upper fixed point and lower fixed point is referred to as fundamental interval. Let me give you a crystal. Upper fixed point is 20. Lower fixed point is 5. That means fundamental interval is simply 20 minus 5, which is 15. So the difference between the upper fixed point and lower fixed point is called fundamental interval. I hope you've gotten that. Let's go ahead. Temperature scales. For this level, we will restrict ourselves to 3 scales. And the scales are Celsius scale, Fahrenheit scale, Kelvin scale. What you only need to know, you need to know the boundaries, that is the upper fixed point and lower fixed point for these scales. Don't forget I told us, I said for our level, we will restrict ourselves to 3 because they are more than that when you go higher. But for because of WAEC, NECO and JAM, we will restrict ourselves to 3. Look at each of them. Don't forget I told us Celsius scale, otherwise known as centigrade scale, Fahrenheit scale, and Kelvin scale. Don't forget we said each of them has 2 fixed points. What are they? Upper fixed point, lower fixed point. I want to tell you, my students, if you know the boundaries, you won't have any problem. Let's go ahead. For example, like this Celsius or centigrade scale, the upper fixed point is 100 degrees centigrade, while the lower fixed point is 0 degrees centigrade. If you come to Fahrenheit, look at it. The Fahrenheit's upper fixed point is 212 degrees Fahrenheit, and the lower fixed point is 32 degrees. However, for Kelvin, the upper fixed point is 373, and the lower fixed point is 273. In other words, you will agree with me that the fundamental interval for Celsius on centigrade scale is 100 degrees. While that of Fahrenheit scale will give us 180 Fahrenheit, because 212 minus 32 will give us 180, because I told you fundamental interval is the difference between upper fixed point and lower fixed point. Similarly, Kelvin scale, the fundamental interval will give us 100. Having said this, then let us put into practice what we just finished a couple of minutes ago. Look at this example. Convert 20 degrees centigrade to Fahrenheit and Kelvin scale. How do you solve this? You don't need to cram. If you understand the concept, I have told you, for you to solve any problem on this, you only need to know the boundaries. That is upper fixed point and lower fixed point. Let's go ahead and see. Losing the information I gave you. We are working between Celsius and Fahrenheit, and we're told to look for 25 degrees, I'll write the upper fixed point and the lower fixed point. Similarly to Fahrenheit, I'll write 212 and 32. Now the question talks about 25 degrees Celsius. Say we should convert it. So 25 degrees Celsius is above 0 degree. I'll put it here, 25. Now we are looking, what is the Fahrenheit? Corresponding value, I don't know. That is what I will put X or Y. Let me put X there. In other words, I will now work on what I taught you. Fundamental interval. That's the difference between upper and lower fixed point. So I'll move on. 100 minus 0 over between 25 given 25 minus 0. What is the corresponding value of 100 with Fahrenheit? That is 212 minus 32 over x minus 32. So I have it 100 over 25 equals to 180 over x minus 32. I have my 100 into x minus 32 equals to 180 times 25. In continuation with what we are solving here, I have my 100x minus 32 equals to 180 times 25. Then I have my 100x minus 3200 equals to 4500. I'll change it. 100x equals to 4500 minus 3200. 100x equals to 1300. So our x will now be 1300 divided by 100. So x equals to 13 degree Fahrenheit. So we've been able to convert our centigrade to Fahrenheit, and that is the method. So I believe you understand this. Having done that, let's go into practice question, and I'll give you 30 seconds to do that. Convert 20 degrees centigrade to Fahrenheit scale. 2. Convert 80 degree Fahrenheit to centigrade scale. I will give you 30 seconds and I'll be right back. Welcome back, my student. We want to look at what you have done and cross-check. Let's go and see. Convert 20 degrees centigrade to Fahrenheit. Like I said, you only need to get the two boundaries, which are upper fixed point and lower fixed point of the two. Let's go ahead. I have my two boundaries. Because I'm working between centigrade and Fahrenheit. So 100, 0, 212, 32. Then I have 20 degrees Celsius. My 20 is 0. So I call this one X. I have 20. So I work between the two. 100, that is fundamental interval, difference between upper and lower fixed point. Minus 0 over 20 minus 0 equals to 212 minus 32 over x minus 32. I have my 100 minus 20 equals to 180 over x minus 32. I have 5. So I have my 180 equals to 5 into x minus 32. So I have my 180 equals to 5x minus 16, 160. So 5x will be equals to 180 plus 160. 5x equals to 340. Let's check. That means our x equals to 340 divided by 5. X will now become 5 in 34. That is 6. 5 times 6, 30. Remaining 4 in 48. So that means our x equals to 68 degrees Fahrenheit. You can use this method to also solve the practice question number 2. That means you work between Fahrenheit scale and centigrade. Until I come your way again, I say goodbye. However, for any question, observation, or comment, do send it to our platform. God bless you.